Welcome to Unit 2, Deformers, Hierarchy, and Visibility. Make sure you're following along with your Cinema 4D open. Before we jump into Deformers, we need to discuss a few things. First, hierarchy and visibility. Hierarchy stands for the relationship of two or more objects. Let's take out multiple objects and look at the Objects Manager. Each object in Cinema's Objects Manager is in a specific list order, but they do not work like layers, meaning the order that they are in the list does not affect how they are viewed in the viewport. These objects are all independent of each other. This means you can alter any one of them and it will not affect the other. Because of this, they are considered peers. Imagine this connecting line is a tree branch, and they are all being connected to one main big branch, the Objects Manager. But you can branch out. If you click and begin dragging any one of these objects, you will notice an icon on your cursor of an arrow with a little square. If the arrow is facing left, you are moving this object up and down in the object's list order. If the arrow is facing down, you are putting the object underneath the one that your cursor is currently on top of. When you have an object that is underneath another one, these objects are not considered to have a parent-child relationship. This means they are not interacting with one another and are no longer independent, as now the child is dependent on the parent. As you can see, if I move the parent object, the child will follow. Same idea if I rotate the parent. These movements or rotations happen in relation to the parent. So rotating this cube does not alter the child's rotation, but it does make it orbit around the parent. Something important to know is that you can still alter the child and the object will not come along with it. The relationship only works from parent to child. As soon as you have a parent-child relationship, notice the negative sign next to your object. This means it has now become collapsible, and if you click on that sign, you can collapse the child out of view. This does not affect the object's visibility in the viewport, so the child is not gone, it's just that the parent now works like a folder. This is helpful for object organization in your Objects Manager. Once collapsed, you see a plus sign. If you click on that, you can bring the child object back into view. To further discuss this, let's talk about null objects. A null is an empty access system in the 3D space. The object contains neither points nor surfaces and cannot be edited like any other object. They are mostly used for grouping objects. You can find nulls in the Create tools. If you take a look at the null's attributes, you can switch the icon that is shown in the viewport, which by default is a dot. But if you want something bigger or more noticeable, you can change the shape and size the null takes. So let's grab a few objects and make them children of the null. Quick note, to select more than one object, you can hold Shift on your keyboard and click from the first to the last object or from the last to the first, similar to selecting multiple files on your computer. You can also make a marquee around the objects you want to select by clicking outside of the objects and clicking and dragging, or hold Control and click each one of them. All of these will select multiple objects. Back to the null. In this case, the null is the parent and all of the other objects are children. Look at how I can move the null and all of the children come along with it. Also notice that if I have a lot of objects, I can organize my Objects Manager by putting them into nulls and collapsing them. This is amazing for project organization and will prove helpful very soon as we begin using multiple objects to create a scene. Now let's talk about visibility. Every object in Cinema has its own visibility, which can be altered. You can alter the visibility of any object using two different methods. The visibility dots, or traffic lights, determine whether an object is visible or invisible in the viewport, as well as in the render. Very briefly, I want to discuss the difference between the viewport, the render, and the render preview. The viewport is this, your main workspace in Cinema. It's where you build and edit your scene on the workplane. Now, the render is the final image output. It's like a picture that you take of your model. So you can think of the viewport as the desk where you build everything, and then the render as the photograph of your final build. Now the render preview is a preview of what your final render will look like. So here in the viewport, we can navigate around, and then when you have the angle that you want to render it in, you can do a render preview. This is going to show you the preview of what the final render will look. You can use the shortcut Command R. You will see that the render preview shows you your Cinema 4D interface, but now the work plane is gone. You have a black void background and you only see the parts that are modeled. If I make any changes here, I will get out of the preview. You can also, instead of using the shortcut, use the button here to render your viewport. But if I am ready to send this to the final render, I will then click on my render to picture viewer. To change the visibility, click on each dot once. The top dot is responsible for the viewport. The bottom one is responsible for the render. Gray is the default, which means visible. So by default, every object you take out will be visible. Green is forced visibility, which means that even if your object is a child of an object that is invisible, it will override it. And red is invisible. Holding Alt or Option and clicking on either of the visibility dots changes both visibility dots at the same time. Object activation is shown as a green checkmark or a red cross. The green checkmark means the object is enabled, while the red cross means that the object is disabled. This is mostly used for generators to activate or deactivate them, but can also alter whether an object is visible or not. Something to note is that if your object is enabled, your traffic light determines its visibility. But if it's disabled, your traffic lights do not affect it. Okay, we're almost getting to the Deformers, but first let's discuss what segments are and how to see them. Segments are the number of subdivisions a specific object has. Subdivision, by definition, is the act of dividing something into smaller parts that make up the whole. By subdividing your objects, you have more room to manipulate your models. So for example, here I have my default cube at 200 centimeters with one segment in each dimension. This means this one segment is 200 centimeters. Now, if I add segments in all dimensions, let's say 4, now the cube hasn't changed size, it's still 200 centimeters, but now that is split by 4, so each segment is 50 centimeters in size. What this means is that now there are 4 new edges that I can use to fold my geometry. Imagine this is a piece of metal and the only places it will fold is where these edges are set. So if you need to create origami out of this, then you would need a certain amount of segments to achieve this. Otherwise, you're left with a strong piece of metal that is not malleable. So you may be wondering, how come you can see these edges on my Cinema, but you probably can't see them on yours? The reason for this is the shading mode of my viewport. On the display menu, you will find shading modes that allow you to alter the way you see your object. This only affects the object in the viewport, so your final render will not show these various shading options. I only want to talk about the first two, so garage shading and garage shading lines. So garage shading is the default shading your objects are in. It is a high quality display where your objects appear smooth and light sources are taken into account. You can see here that my default Cinema 4D light gives me a brighter and darker side to this cube. Other modes such as constant shading do not allow for this. Next is garage shading, but this time with lines. What these lines are showing you are your object's wireframe. In other words, the lines that make up your 3D model. We don't need to jump too deep into this as long as you understand that this is garage shading and this is garage shading lines that shows you your wireframe. Alright, now we can jump into deformers. There are more than 30 different deformers, so we'll obviously not cover a lot of them. Some of the ones not covered are simply better used for animation or more advanced than what we need to learn for this class, but feel free to experiment with them. Deformers are used to distort the shape of objects in an exact mathematical way. The advantage of this is not having to push or pull points, so difficult shapes can be created very easily. They're also non-destructive, which means that it does not destroy your geometry, so you can always go back. The disadvantage is that they only do so much, and you cannot fix individual polygons, lines, or points. By themselves, deformers don't generate geometry. They're just these empty bounding boxes, so they must interact with an object. The easiest way is by making deformers children of the object they are trying to deform. But they can also affect their peers if both objects are children of the same parent. Most deformers that we're going to talk about have certain attributes that are similar. First, size, which is the size of the deformer, meaning the bounding box. Then alignment, which defines the axis in which the deformer will work. Notice how the arrow within the bounding box changes as I change my alignment and hit fit to parent, which we will cover in a second. This is an illustration of what the positive y, negative y, positive x, negative x, positive z, negative z looks like. The auto option will let Cinema assume which dimension you want. Something else that deformers share is their mode, which can be limited, within box, or unlimited. Limited means that the entire object is affected regardless of whether the bounding box is covering the entire object or not. The parts that are not inside of the box accommodate to match whatever the deformer is trying to do. Within box means that only the surfaces that are within the box are affected. Everything outside of the bounding box remains unaffected. Unlimited means that the entire object is similarly affected, and there is no need for accommodation since everything is happening equally. Lastly, the Fit to Parent button adjusts the size of your bounding box so that your deformers can fit whatever the size of your parent object is. Just want to go back to segments for a second, since it is the top sentence of every slide from here on out. The first deformer that we will use is a bend, which bends your object. Now imagine I give you a piece of PVC pipe and told you to bend it. This would be a difficult task. Now if instead of that, I cut up the pipe by adding subdivisions and turn it into a slinky, now if I ask you to bend that would be a much easier task, right? This is because your bending is no longer going from A to B. It's now doing A to B to C and so on and so forth. So if now in Cinema I take a cube, take out a bend deformer by clicking on the deformer menu once, since the bend is the first deformer, or I can also leave it pressed and letting go above the bend. Put this bend as a child of the cube and increase its strength, which is how much it is bended. You can see that it's trying to bend this cube's one segment from A to B. But if we go to the cube's properties and add more segments, you can immediately see how the deformation of the bend is taking effect on the cube. Now it is trying to match this bend a lot better. Make sure that you pay attention to which segments you are increasing, because in this case, the bend is mostly affecting this part of the cube, which is Y. So I need more segments in Y. Adding segments in X or in Z wouldn't really help me with this particular bend. They would, however, help me if I was bending in X or in Z. The more segments, the closer your geometry will match the deformer. But keep in mind, there is such a thing as too many segments. Every segment needs to be calculated by your computer as individual pieces, so make sure to only add as many as you need. Otherwise, Cinema can crash. It is unlikely that you will go over 50 segments for anything. Next, in the bend, the previously mentioned alignment, notice that the bend follows whatever the alignment arrow is pointing to. Make sure to hit Fit to Parent so that the alignment change will take effect. Angle changes the angle that the bend is occurring in. This changes the direction but not the dimension. The Keep Y-axis length, if checked on, keeps the height of the object the same, but if checked off, it allows your object to stretch beyond the object's original size. Next, we have bulge. Once again, this deformer needs segments in order to smoothly do what it is designed to do. Bulge creates a bulge in your objects, but you can also go inwards. The strength determines how much is actually bulging, or whether it's inwards or outwards. This deformer also has curvature, so you can make it curvier or straight. And then finally, a fillet option, which, when checked on, eases the bulge near the top and the bottom. Then we have shear, which, again, segments. Shear skews an object's top. It has all of the properties that we have already discussed, but now they apply to how the object is skewing. Taper tapers the top of an object, making it small or big. Once again, you have size, mode, alignment, strength, curvature, and fillet. Make sure that you are trying these out for yourself. Then twist, which twists the object, and it only has size, alignment, mode, and angle, which in this case, it's actually how much is twisting. Twist is a good one to have a lot of segments for in order to get a nice smooth twist. We also have spherify, which deforms an object into a spherical shape. This deformer has two properties, radius and strength. Radius is similar to size, and strength is how much it is rounded and resembles a sphere. Notice this one does not have mode. The last one that we will cover is the FFD, Free Form Deformer. This one is special and different. It deforms an object by using grid points. The more grid points an FFD has, the more that you can manipulate it. Once again, segments are incredibly important to determine how smooth the manipulation will be. Quick note, I tend to make my FFDs 1 centimeter bigger than the object that I am using because by clicking on Fit to Parent, the FFD sometimes gets lost within the geometry of your object. So because I want to be able to see it better, I am making it slightly bigger. To use this FFD, you have to not only make it a child of your object, but you also have to be in point mode. We will cover this at a later presentation, so the only thing you need to worry about right now is that this is model mode and this is point mode. Because FFDs give you points, you need to be in point mode to actually see them. Otherwise, you always want to be in model mode for now. To select a point, you want to change to your brush selection tool, shortcut 9 on your keyboard, and click on any of the points. If the point is highlighted yellow, that means it is selected. If you click and leave it pressed, you can select multiple points as if you had a paintbrush. To add to your selection after you already have let go of your mouse, hold Shift on your keyboard and continue clicking and dragging. Quick thing I want to say about selecting points and selecting objects. Your axis will always be at the average of whatever you are selecting. So if I'm selecting only one object, my axis, if I have not changed it, will always be at 0, 0, 0 of that object. However, if I am selecting two objects that are away from each other, my axis will be at the average of where these two objects are. Same thing works with points. If I'm selecting 2 points, my axis will be in the average of where these 2 points are positioned. Back to the FFD, if I increase the grid points in the attributes, you can see how many more points now I have to select. If I want to select all points at once, the shortcut for this is Control or Command A, similar to how you select things outside of Cinema. Make sure that you are in your viewport when you select Control or Command A. Otherwise, if the last thing that you clicked was your object manager, Control or Command A will select all of your objects instead. The way the FFD works is that it allows you to select certain points and manipulate them individually, so you can move them, scale them, and rotate them. Imagine that they're their own little tiny cubes that you can select and move. More grid points means more points to alter in the FFD. But remember that for it to be smooth, you also need to have segments on your cube. Play around with your FFD. It is a very handy deformer and a great introduction to altering points, which is something that we will learn a lot more of later on. As a reminder, deformers are non-destructive and will not permanently affect your object. To delete them, or to delete any other object, select them in your object manager and press backspace on your keyboard. You can also use the object activation to turn on or off your deformer so that you can see the changes it is making. Let's talk about stacking deformers. You can use several deformers on the same object. Simply keep adding more as children of the object. However, the order matters. A taper followed by a bend produces a different result than a bend followed by a taper. Think about what action you want to happen first and then make that the first child of your object. Whenever you are done using your deformer, I want you to hide it from the viewport, and you can hide it from the render as well, even though you wouldn't be able to see it there regardless. The reason for this is that sometimes when dealing with a lot of deformers, that bounding box can get in the way visually and now allow us to see the actual geometry that we are working on. So use your visibility dots to hide the deformer so you don't have to see the bounding box. Don't use the object activation, as that will turn on or off your deformer instead. You want to hide it, not deactivate it. Some tips and tricks. You can deform multiple objects at once with only one deformer. If you remember at the beginning, I mentioned that a deformer can't affect its peers if both objects are children of the same parent. This is where nulls can be really helpful. So here I have 2 cubes. I'm going to make this bend big enough to cover both cubes and add all of them as children of a null. You can see how it's affecting its peers. Somewhere else the null comes in handy is when altering the object's axis. There is a button called Enable Axis, which is a mode that allows you to alter the axis of an object. Using the L shortcut on your keyboard, you can switch quickly to this mode and back. You can also switch by mistake, so just be aware wherever your object's axis is where your movement, scaling, and rotation will happen from. Your object's axis comes out at the center, which is why everything usually happens from the center out. Think of this as your anchor point in Photoshop. Primitive objects prevent you from changing their axis, so we're going to use a null to work around this. Making a primitive object the child of the null and then changing the axis of the null, we can use the parent-child relationship to now move, scale, and rotate the cube from its parent, which is the null. The way that enable axis works is that you turn it on, you make the changes to the axis, and then you turn it off. It's as if you're unlocking the axis to allow you to move it. This is only changing the axis of the null. The cube's axis in this case is staying the same. You can use the Reset Transform button found within the Coordinate Manager to reset the transformation of your objects and your nulls. So for example, if you made a change to your null's axis that you want to revert back to its original state, 0, 0, 0, then you want to select it, enable axis, reset transform to both the null and the cube so that both of them come back to 0, and then turn off enable axis. Before we wrap up, I want to mention a little asterisk at the top of your Cinema 4D window. If you see this asterisk, it means that the latest changes to your file are not saved. Please keep in mind that if you save your file, but then make further changes to it, you will get this asterisk as a reminder that you need to save the latest version of it.
Here we have some common problems and how to fix them. First, let's say you're trying to affect the strength of your deformer, but nothing is happening. Make sure that your deformer is a child of the object that you're trying to deform, and that you have increased or decreased the strength. Second, you're trying to get a smooth deformation, but it is showing blocky. Make sure you select your object and increase the segments in the correct dimension. If your object is showing up in the viewport but not in the render, or the other way around, make sure you check your visibility dots. Lastly, if your object is breaking or not showing up as desired, make sure you check the mode of the deformer and that the bounding box is surrounding the entire deformer. And if you're using multiple deformers, make sure that they are in the correct order in the Object Manager.
And this is the end of this video. I'll see you for the next one.